Good morning, grade 8s. We're starting fractions today, our new unit. And I want to do a little intro to fractions today. And the first lesson is going to be on equivalent fractions. Okay? So we'll start off with what is a fraction. I know you've seen fractions, but we want to make sure that you can make sense of a fraction. Okay? So fractions are basically a number. I know we talk about the two numbers in fractions and we have names for them, the top and the bottom number, but really when they're put together they become a number. And it's a number that describes part of a whole, okay? Or part of a group. So to make sense of that, we could have a whole pizza. Okay, wasn't a very well-drawn pizza, but there's a circular pizza. And that pizza could be cut into 4 pieces, and you might be served one of those 4 pieces. So that's the part of the whole pizza that you got. Okay, and that fraction would be equal to 1 piece out of the 4 that you got. Okay, now it could also be part of a group. So instead of your mom making 1 big pizza, maybe she made 4 mini individual pizzas, right? And that would be a group of pizzas. And you were served 1 of those 4. Again, this would be 1 of a group of 4, and it can also be written as a fraction, okay? Now, we have talked about in the past, right? The names for the top and the bottom number in a fraction. So the numerator, that is the top number. And what does that represent? That represents the number of equal parts being considered. Okay? So if we think about up here in terms of this pizza, right? The part that we were considering was the 1 piece that you ate, right? Or the 1 mini pizza that you ate. We weren't considering the 3 pieces you didn't eat or the 3 mini pizzas you didn't eat. That wasn't what we were considering. So the top number is the part that you were considering. Okay, you're going to be asked on a quiz or a test to identify the numerator. So if I gave you a fraction like 2/3, you would tell me that the top number here is the numerator, okay? Now, moving on, we have the denominator being the name for the bottom number. And what is that? That is the number of equal parts in our group or in our whole or group, right? So when we talk about that pizza again, how many equal parts was that pizza cut into? It was cut into 4 pieces. How many equal size mini pizzas did we have? Well, we had 4, right? So that's the number of equal parts. So again, if you had a fraction given to you on a test like 2/3 and you were asked to identify the denominator, you simply had to identify the bottom number, okay? Now, moving on, we have the term equivalent fractions, right? And I'm hoping that you can see in here the word, right? Thinking of the word equal, okay? And equal is the same thing as equivalent, okay? So it is fractions that represent the same part of the whole or the group. Now, if we were to think about this in terms of pizzas again, okay, I'm going to draw a pizza and I'm going to copy that and draw a second pizza and we'll put it here and we're going to make these equivalent, okay? So let's say your mom baked a pizza. And again, she cut it into 4 pieces, and you were served 1 of those 4 pizzas. So this is equal to 1/4. Now, if we want to create an equivalent to that, and the pizza, instead of being cut into 4 pieces, let's cut it into 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. And those are supposed to be equal size pieces. If we were to give you the same amount or an equal amount of pizza, how many pieces would you have to have, right? You would have to have 1, 2 pieces. So to be equal, you'd have to have 2 pieces in a pizza cut into 8. Now those are all equal to each other, right? To create equivalence, you have to have the same amount of pizza, but the size of the pieces are different, okay? 1 piece here is equal to 2 pieces here, okay? Now, we don't want to go around drawing pizzas all the time to find equivalence. So there is a rule for us to do this, right? So the rule for finding equivalence is a lot easier than drawing pictures. So what do? We multiply the top and the bottom by the same number. Now, we can't use 1 because if you multiply something by 1, it doesn't change the number. Okay, so let's look at an example here. If you had 1 over 4, the same pizza size as our original one up here, and we wanted to create an equivalent or an equal one to that, we could take and multiply the top and the bottom by the same number. So let's pick a number not too big, but bigger than 1. Let's pick 2. So we're going to multiply the 1 at the top by 2, so 1 times 2 is 2. Multiply the bottom by that same 2, and so 4 times 2 is 8. So that's another way of creating an equivalent. Look, we've got, in fact, the same or an equal fraction, okay? Now, you don't have to pick 2. You can pick any number other than 1. So we could, in fact, take that same quarter, and we could multiply it by something bigger. Let's multiply it by 5. So 1 times 5 is 5, and 4 times 5 is 20. And guess what? These are also equal. 2 over 8 is also equal to 5 over 20. Okay? All of those are equivalent. Now, the next thing we need to talk about is lowest terms. And lowest terms is another equivalent fraction. Okay? But instead of multiplying, what we do is we divide. So lowest terms, whoops, I don't want to be crossing that out. I just wanted to highlight it, is often referred to as simplest form, and it is an equivalent fraction, okay? It is a way of writing the fraction so that the top and the bottom have no common factors other than 1. Well, what does that mean? We can't divide the top and the bottom by anything other than 1. So the rule for doing this is to simply divide the top and the bottom by the same number until there's only a common factor of 1. Okay, so let's look at some examples for that. Okay, we'll have 3 over 9. So we want to go lowest terms. So we're looking for a number we can divide the top and the bottom by. So when you're doing this, you want to think about your divisibility rules, right? 3 is a prime number, so it only divides by 3 and 1, because the only way to get 3 is 3 times 1. Well, we know we can't use 1 as a factor, but we could divide by 3. And that's also true for the bottom. The bottom will also divide by 3. So 3 divides by 3 to give you 1, and 9 divides by 3 to give you 3. So this is the lowest term possible for that fraction, because 1 can't go any lower. Okay? Now, sometimes we're given a fraction that is a lot bigger, and it may take a number of times to reduce this to as low as possible. Let's look at the example 36 over 72. Now, thinking about your divisibility rules, what could we divide 36 and 72 by? Well, I'm hoping that a lot of you decide that it's an even number on the top and the bottom, so that means it would divide by 2. So 36 divides by 2, well, half of 30, remember, is 15, and half of 6 is 3, so when we put it together, we're going to get 18, right? Half of 70 is going to be 35, and half of 2 is 1, so that's going to give us 36 at the bottom, okay? So dividing by 2 gave us 18 over 36. Now, we're not as low as we can go because recognizing these are both even numbers again, right? So we can divide them both again by 2. So 18 divides by 2 to give you 9. If you're not good with 36, you can go 30 divided by 2 is 15, and 6 divided by 2 is 3. Put them together, and you're going to get 18. Okay? Now, we're still not as low as we can go. Even though 9 can't divide by 2, there is another number 9 can divide by. I'm hoping you recognized up here that we divided it by 3. Remember your rules, right? If the sum of the numbers can be divisible by 3, so 9 divides by 3, and then 1 plus 8 is 9, so both of those will divide by 3. So 9 divides by 3 to give you 3, and 18 divides by 3 to give you 6. Now, this is still not as low as it can go, right? We could divide again, because I'm hoping you all recognize that 3 divides by 3, and so does 6 divide by 3. So 3 divided by 3 is 1, and 6 divided by 3 is 2. There's our final answer. Now, that was a lot of work. Some of you may have recognized that you could divide by a bigger number than 2 or 3. Some of you may have recognized that 36 divided by 9, and you could have done that right away. You could have taken 36 and 72 and divided them by 9. Okay? 36 divided by 9 is 4, and I made a mistake there. 36 divided by 9 is 4, and then you're going to go on and take 72 and divide it by 9, and I'm hoping you recognize that that's 8. Now, looking at this, you know it can divide to go smaller, so you could divide by 4 on both cases to get to the lowest terms as quickly as possible. So 4 divides by 4 to give you 1, and 8 divides by 4 to give you 2. Okay? Now, some of you may have even recognized that 36 could divide by 36, and so could 72, and divide by 36 right off the bat to get to the answer. Most people wouldn't recognize that. You may have to do it in a number of steps. If you choose bigger numbers, you get to that lowest terms faster. All right, ladies and gentlemen, you've got a worksheet to work on called equivalent and lowest terms. All right, take care. See you soon.